Hello, I'm going to introduce our poster, Development and Validation of a Portable Device for At-Home Hydrogen and Methane Breath Testing for this presentation at the ACG 2024 conference. Hydrogen and methane breath tests, also known as HMBTs, can be used in clinic to diagnose small intestinal bacterial overgrowth and carbohydrate malabsorption due to the connection between the levels of these gases in the breath and the activity of the gut microbiome. Longitudinal measurement of hydrogen and methane also allows for monitoring treatment response and early detection in disease recurrence. For this purpose, OMED Health has developed a portable hydrogen and methane breath analyzer device. In this study, we completed several validation tests to measure the accuracy of this analyzer device. We developed a gas concentration predictive model simulating human breath and allowing us to measure the concentration of hydrogen and methane within a mix of gases. We also benchmarked the OMED breath analyzer device to an in-clinic hydrogen and methane analyzer, the gastrogenius breath monitor, using the breath of human volunteers. 941 synthetic breath exposures were included in this study, and the desired concentrations of hydrogen and methane were generated by calculating the ratios required of constituent supply gases in a synthetic breath gas flow. The results found that the sensors within the OMED device, an analytical model utilized as part of the device, can accurately assess and report hydrogen and methane levels. The OMED device was then compared to a clinically validated HMBT instrument. A total of 243 breath samples were collected from 54 participants. Each participant gave 2 samples into the HMBT, and the mean was calculated. In between both samples, the participants gave an extra sample into the OMED device. Treating the results of the average of the HMBT as a truth, there was a comparable calculated error for hydrogen and methane between HMBT and the OMED device. In a preliminary study assessing the diagnostic performance of the OMED device, this has shown a high degree of concordance with the HMBT tests, achieving more than 90% accuracy in both SIBO and IMO diagnoses. In conclusion, this data suggests that the OMED device is highly accurate with comparable performance to an in-clinic HMBT. The added portability for convenience and the possibility of taking regular at-home measurements can provide significant benefits for users by providing longitudinal data that it is immediately available for their healthcare provider. Thank you for joining me and hearing more about our poster today. I hope you enjoy the rest of the conference.